On page 1 of section 3, we have listed for you some of the byproducts of the spare parts where used list. And I'd like to walk through these with you and make some comments when comments are necessary. The first byproduct is a list of all of the equipment, the machinery, or assets where the spare part is used in. Now, this is extremely important for 3 reasons. First, to process an engineering change notice so that if I were going to change a spare part, I knew specifically all of the equipment or assets where that spare part was found in. Secondly, to process an obsolescence program. And thirdly, the input into what I call the inventory management program for future unplanned requirements. And the spare parts where used list provides what we call a spare parts where used code. It's a numeric number. And if I had a spare part that was used in one asset, it would have a where used code of 1. If another spare part had a spare part code of 10, that means that that spare part is used in 10 pieces of equipment or assets. The concept of the where used code is as follows. The higher the where used code, the higher the probability that there is going to be a future unplanned requirement. And you'll see as we go into section number 4 in the inventory management program of the stores program itself, we have developed a matrix that ties together the where used code, a service level or a fill rate out of the storeroom, and the associated safety factor that comes from a service level safety factor table, which helps us to develop the amount of inventory we want to carry for future unplanned requirements. Number 2 indicates the ability to process engineering change notices, which I had just indicated. 3, the ability to process equipment and spare parts obsolescence programs. And again, I've talked about that previously. 4, the creation of a where used code to assist in the development of future unplanned requirements. Now, we show item 2, 3, and 4 individually on this list, even though I had described them, but we'll actually show you how they're processed and implemented. The ability to develop spare part standardization programs is also a byproduct of the where used listing. And the last is the ability to develop spare parts cost reduction programs. And that is tied in with vendor stocking programs where we can purchase items for lesser cost once we implement the vendor stocking program. Now, as you work with the spare parts where used list, you undoubtedly are going to develop some additional byproducts of the where used list. Please add those to this particular list, because this list is used to train the planner scheduler, the inventory management person or persons, the purchasing management person or persons, and all people that are working in the storeroom to support the storeroom management program. This is the type of integrated training that is required to support many of the items that are mentioned on this particular exhibit. Now, the next page addresses a particular list of 4 pieces of equipment, and they are identified as A, B, C, and D. And the individual numeric numbers that are tied in with each one of those pieces of equipment are shown by their bubble number. As an example, equipment A has part numbers 1, 2, 3, 4, and 5 as an integral part of its equipment spare parts list. And the same description applies to B, C, and D. Now what we're going to do is we're going to convert this document, page 2, which is the equipment spare parts list, into the spare parts equipment where used list. So if you turn to page number 3, we're showing you up on the top the bubble numbers, that is the part numbers that are all found on the previous page, part numbers 1 through 9. Now, if we would flip back and forth between the preceding page and this where used page, you'll see that the square boxes that represents the equipment identifies the various equipment that the part is used in. As an example, part number 1 is used in equipment A and C. Part number 2 is used in equipment A, and subsequently part number 3 is used in A, B, and C, and so forth. Now at the bottom, you'll notice that we have the where used code. That where used code, as I indicated a few moments ago, is a numeric number which merely indicates the number of pieces of equipment that spare part is used in. So again, going from left to right, part number 1 is shown as being used in equipment A and C, so it has a where used code of 2. Part number 2 is only used in A, so it has a where used code of 1. And the balance of the where used code numbers are a byproduct, again, of the number of pieces of equipment that the individual spare parts are found in. Now, if you would turn the page to page number 4, I'm going to walk you through step by step how an obsolescence program should be introduced. First of all, the step 1 indicates that we're going to take asset A, which is equipment A, page 2 from service. We're going to remove it. So the first thing that we would have to do is to get the spare parts list for asset A, and that is found on page 2. So now we have the equipment A and the spare parts list that will be obsoleted. However, we dare not obsolete the spare parts until we determine if those spare parts are used in any other asset. So step number 3 is the development of the spare parts where used list, which is found on page 3. And step 4 indicates that the part numbers 1, 3, 4, and 5 are used in other assets, but step 5 indicates that part number 2 is only used in asset A or equipment A. So therefore, we have identified immediately that part number 2 is a candidate for obsolescence, and therefore we should now develop the procedures to remove equipment A from operation, and likewise determine how we're going to dispose of any spare parts that may be in the storeroom under part number 2. And that is the balance of the procedures that are shown in steps 7, 8, and 9. And as I indicated to you earlier, If you follow the procedures as outlined on page number 4, but you can't do that until you have developed your equipment spare parts list first. Secondly, develop the spare parts where used list. And if you have those two in place, I will guarantee if you follow the procedures on step 4, you will never have obsolescence in your storeroom unless you somehow made a mistake. Now, the next page on 5 addresses the where used code procedure. And again, I've identified how we developed the numeric number, but let's just go through the steps to make sure that you can identify each one of the steps in relationship to the instructions. The first step is to get the spare parts where used list and translate that number, okay, into its numeric number. And we did that for all of the spare parts previously, spare part numbers 1 through 9. That was that where used code on the bottom of that exhibit. The second step is called the where used code number. It is a numeric number. Third, the higher the where used numeric number, the higher the probability that there's going to be an unplanned requirement. So what I'm doing now is I'm cross-referencing this section 3 to section 4 and especially to page 28, which identifies the relationship between the where used code, the spare part service level, and the mean absolute deviation to develop the type of inventory that we want to carry in stores for future unplanned requirements. We will go through the complete development of that particular ordering matrix on page 28 in section 4. Item 5 indicates that the service level percentage as shown on page 28 section 4 has been selected by many companies like yourself, as a byproduct of the where used code. The service level percentage is a maintenance management decision relative to the service, or what I called previously the fill rate out of the storeroom. And remember, the higher the where used code, the higher the probability that there's going to be a stock out. And step 6 indicates that MAD, mean absolute deviation, which is calculated, and again we'll show you how to do that, how that safety factor for a pre-selected service level is found on page 27 in section 4. So without further ado, we're now going to move into section number 4, which is the inventory management of the spare parts. And you will notice that as we go through that section, I will be addressing how the inventory, the purchasing, and the storeroom program are totally integrated with each other. In section 4, our inventory management section, we're going to address all of the various data elements relative to inventory management. We're going to address inventory policies, the various inventory control techniques that should be considered in the inventory management program. We'll address the 2 questions: how much should we order and when should we order? We will look at the development of the various inventory control techniques. And in this section, we also have some illustrations as to how these techniques actually work. And as we go through the material, we'll show the interrelationship of the inventory management program to both the purchasing and likewise the storeroom or the crib. Now, starting off on page number 1, we're going to address some of the data elements that you want to consider in a part number item master record. In fact, the data elements actually are concluded on page number 2. So you would have the ability to do some cross-referencing from these title pages, that is pages 1 and 2, to some of the other data pages in this section. I'm going to provide you with some cross-reference data. So as I go down page 1 and 2 and talk about the specific data elements, I will likewise give you page numbers that I would like to have you record alongside of the item that requires the cross-referencing. Then at a later date, when you want to use the notebook for internal training, you'll have this cross-reference capability without trying to determine, you know, where did Frank discuss this and what page was it and what section and so forth. So let's start off with item A. We have the spare part number. Now that is of the spare part, and don't forget, our interpretation or identification of a spare part is not only the physical spare part itself, but it also can pertain to lubrication and any media required, like filtration media, lubricating media, HVAC, filtering media, or any other item that will be required by the maintenance department to support a maintenance work order. B is the spare parts description, and C is the unit of measure. Now this unit of measure is the unit of measure that is also found on the equipment and its associated spare part listing. A little later, when we get into section number 5, you're going to find out that we have what is called the purchase unit of measure, which could be different from the unit of measure that we have in our inventory system. And I might also indicate that the unit of measure in storage would be also the same unit of measure that is in the spare part record and also the inventory management record. Moving to item D, inventory classification code. Now make a note to yourself that that listing for the inventory class code is found on pages 5 and 6. The ABC code starts on page 12, and that is to identify all spare parts in terms of their annual usage value. And we will go through the definition of the ABC coding, and again we have an illustration or an example on how it actually works so that you can implement all of these techniques and applications directly from this seminar and from the notebook that you are provided with. The cycle count frequency, which is item number F, will also be shown as an integral part of the ABC system, because you cannot really start cycle counting unless you develop your ABC classification. The requirements are those spare part requirements from either planned or unplanned maintenance work orders. So therefore, the inventory record should consist of 3 sub-records for each part number. The planned record should indicate those items that come from planned maintenance work orders. As an example, planned maintenance work orders can be those that are a byproduct of the PM program, major, minor overhauls, or planned projects. The unplanned requirements come from those maintenance work order requests that come from anyone within the organization requiring maintenance support. And then that request gets converted over to what we call an unplanned maintenance work order. The total is the sum of both planned and unplanned requirements where the item is used in both cases. The on hand is the total on hand, and it does not take into consideration individual storeroom locations or bin locations within a storeroom. It's the sum of all on hand. The on order is also the total on order. So basically what we're doing is we're summarizing at any point in time all of the on order requirements, either through the purchasing system or through the manufacturing order replenishment system. The repairs is a item that I hardly ever see in any inventory system, and that is I can have a repair done internally, I could have one done externally, and there may be times, depending on volume, that I could have the same part number be repaired on a purchase order and another same item be repaired on an internal maintenance repair order. And then we also have to keep track of the total. Now, the reason for the repairs being an internal part of the bin on hand is that the repairs are your assets. When you do cycle counting, you want to count those assets even though they may not be usable, but they are still available prior to repair, but will be usable after repair. So repair orders, whether it's purchased or manufactured internally as a repair, should have completion dates. Now, moving on to page number 2, we have different inventory control techniques, and in this case, you should make a note that those techniques are going to be found on page number 9. For each technique, we have a code, which is demonstrated by K1. Now, if there are more than one person that will be managing the inventory system, then we want to find out not only what the code is, but the date the code was established and the employee by, let's say, badge number or maybe name, who that employee was that established that specific inventory control technique code. Likewise, we have the unit cost, which is really the cost of purchase or the cost to manufacture. We have the inventory carrying cost, which is item M. Now, again, make a note on page 20. We will show you the data that comprises the carrying cost. The purchase ordering cost, item N, will be described in detail on page 21. And then we have the lead time, and that's the lead time of the item, which we call aggregate lead time. It's not the purchase order lead time as quoted by a supplier. You may have more than one supplier. You may find that there may be several lead times depending upon the number of suppliers. What you want to do is to identify maybe an average lead time that would take into account more than one supplier's lead time. Let me define the elements that are part of aggregate lead time. The first element would be the pre-purchase order lead time. That's to analyze an inventory record when, let's say, a purchase order has to be generated. Then there is the actual placement of the purchase order, so we call that purchase order lead time. Then there's the vendor lead time, and that's the lead time that is quoted by the supplier and is recorded in the purchasing system. Then we have transit from the supplier to your shop. We have the receiving lead time, the receiving inspection lead time, and last, the lead time that it takes to actually put material bin on hand. You see, a well-designed inventory management system does not recognize inventory in a receiving department. We could show it as a window in the inventory record. But bin on hand is the true indication that material is available for future use for either planned or unplanned requirements. And then we have the shelf life code, item P, and the shelf life code is described for you in section 5, page 2. So these are the cross-references that I identified earlier, and it will make it easier to move from this item master record list to the various pages within the balance of the notebook where that data actually is developed. Now again, what other information do you require? Please add it to this list and make certain it's in your item master record. Now we're going to move toward the development of what I call the inventory management program. The inventory management program is equal to a formula that I designed many, many years ago, and it goes as follows: inventory policy plus inventory technique. Policies are established by top management. They're approving the way the inventory management program is going to function, and the inventory technique is the actual implementation of those policies in the inventory management program. Now, the next 2 pages, pages 4A and 4B, addresses some of the major policies that you may want to consider in your inventory management program. These should be understood by top management, and they should also be approved and supported by top management. First, the different inventory control techniques that we're going to utilize. And in a moment you'll see those are identified not only by the way the technique is applied in inventory management, but it also is used in the development of our inventory ordering matrix, addressing the 2 questions: when should I order and how much should I order? Inventory control levels, if you will, of all commodities and or classifications. A commodity is a family of parts: bearings, AC motors versus DC motors, hardware type items, plumbing supply items, certain electrical products broken down into families. Those are commodities. The commodity part number is preceded by generally a 2-digit first field called the commodity or family code. Now, that commodity or family code is going to be extremely important to the storeroom, because that's how the storeroom should be laid out. And when we get into the storeroom section, we do have some different layout diagrams indicating the different approaches to not only laying out the storeroom, but how the bin location system can be defined. Now, classifications are those inventory classes that are identified in the following pages after we finish up with the policies. The stocking locations, you either have one storeroom, which is centralized, or you have decentralized storage. My only comment with respect to either centralized or decentralized is that they must be secure. And you're going to hear me talk about storeroom security all through the balance of this program. The inventory system will not work properly. It will not be supported properly by the purchasing system if the storeroom itself is not under a secure environment. Now, item 4, service levels, safety stock for replacement parts is part of the inventory technique to generate bin on hand for future unplanned requirements. And again, we're going to go through the development of that particular technique. Inventory turnover is how well am I utilizing inventory. Over the period of years, we have been compiling statistics relative to craft utilization, inventory turnover, and many other applications. On an average, the storeroom inventory turns 0.93 to 0.95 turns per year. The 0.9 means we're turning less than 1 turn a year. If you were in business as a storeroom supervisor, and that was, let's say, your hardware store, and you were getting less than 1 turn a year, you wouldn't be in business for more than 2 to 3 months. We want you to have the ability to measure turnover by both family code and by commodity code. We also will show you how to develop turnover analysis by individual part number. And if you want, we will also show you how to utilize turnover analysis by total inventory on hand minus some of the inventory class codes that are going to be in the storeroom, but only to be used based upon, let's say, emergency requirements. So inventory turnover is going to be very important, and I know your top management is extremely anxious to see how you can increase the number of turns by using modern inventory control applications supported by vendor stocking programs. And we will discuss vendor stocking programs in this section. Obsolescence policies, we went through that in section number 3, and all you have to do is go back to page 5 in section 3 and review the obsolescence program. No storeroom should have obsolete material in it. But if you don't have the proper data and the proper maintenance management system, then you're going to be stuck with obsolete inventory. Disbursement procedures and policies represents the recording of all issues out of stores. Nothing goes out of stores without it's being recorded. And this is true for those of you that have second and third shift storeroom applications. Cycle counting replaces the physical inventory, and it is done more frequently during the course of the year, in some cases daily. And again, it's the byproduct of the ABC code, and we will, as I said earlier, go through the development of the cycle count program for you. Security requirements, enough said. Lock the storeroom up. Only authorized storeroom personnel should be allowed in the storeroom. 10 is a new part notice system, and we described that previously in section 2. Likewise, the engineering change notice system, item 11, that was described in section 2. Now, when you look at 12 on top of page 4B, we're going to discuss counting equipment. Everything that is received into the storeroom must be counted. How can you count small items that are in, let's say, larger quantities? You're certainly not going to sit there and count by the ones. You may need a balance scale, a ratio scale, a weigh scale, scales of different nature to count the various items or commodities that are coming into your storeroom. Remember, the counting process emulates what you're going to put bin on hand, and that bin on hand is going to be used by the inventory system. Don't assume that the supplier's packing slip is accurate. Count the material and put it away. When you develop what we call a vendor verification or vendor auditing program, where you are actually recording for key items the quantity received, the date received, and also the quality of the items, then you could use that data for the input into a vendor certification program. The vendor certification program will support that acronym JIT, just in time. And yes, JIT is applicable in the maintenance organization. But the two data elements that have to be in place is number one, the maintenance work order planning and scheduling system must plan and schedule planned orders, and the inventory system has to record those planned order requirements. Once you establish that, you can establish a vendor stocking program and have the vendor deliver the material to you directly into the storeroom, or in many cases, clients of ours that we have provided services to, the supplier is actually delivering the material right to the job site. So there are some key benefits with some of these inventory policies and the disciplines that are associated with the execution of these policies. Receiving inspection, item number 13, is again an integral part of a self-contained storeroom. Now, the type of inspection we're talking about here are those inspection functions that measure maybe the length and the thicknesses of items, the OD, the ID of items, and there are other applications such as vendor certified inspection documentation. When let's say a shipment is received by you in the storeroom, or you can establish third source suppliers that could actually do some of the testing and inspection for you. But that is becoming a very key and critical item within the storeroom, because as inventory is reduced, the count must be 100% accurate and the quality must be 100% perfect. We also have to consider different training programs for the storeroom, the inventory, and the purchasing system. And when we get into the storeroom section in this notebook, we will discuss an outline of very, very detailed, comprehensive training programs for the storeroom. Material handling equipment, as identified by item 15, is a identification of the various types of material handling and transporting equipment that you may need to support the maintenance management planning and scheduling work order system. We also have to consider proper storage facilities within the storeroom. That is addressed by item 16. There are many companies that have humidity, temperature, atmospherically controlled chambers where certain items are stored in. We also have to consider storage requirements that are outlined by OSHA, outlined by the EPA, or maybe even recommended by your own insurance agency. And that's basically what we're alluding to. You'll see as we move into the storeroom program that we identify different storage requirements through a coding system, and that coding identification item is recorded in the item master record, which automatically indicates how an item that must have special storage requirements, how that item is to be stored. Second and third shift support is going to be key, especially if there is no full-time person in the storeroom. There are different applications to support this, and we will again review those when we get into the storeroom section. The shelf life program is an expiration date indicated or originated by the OEM of the spare part. It can be permanently marked on the part number, or it could be marked on the package or the container which houses the item. The shelf life item must be recorded in the storeroom, and the storeroom, as I said earlier in this program, must assume the responsibility to continually peruse through your inventory bin on hand system utilizing the shelf life codes. And again, we'll go through the application of the shelf life program. Receiving conversion capability are for those items that have let's say a vendor unit of measure as compared to our unit of measure of storage and subsequently issuing. As an example, if I purchased one, which is a unit of measure, box of hacksaw blades, I know and you know that there are 10 hacksaw blades in a box. So the conversion for that part number would be 10. If, on the other hand, I purchased, let's say, a spool of solid strand red-coated wire 12 gauge, and the spool could be in either increments of 3, 4, or 500 feet. The unit of measure on the purchase order is one spool. But when that item is put into the storeroom, depending on the number of feet per spool, we're going to record X number of feet on hand, X number of feet being received against that purchase order. So conversion applications are going to be very critical to maintain the data integrity of bin on hand for those particular items. Extra security items that are indicated on page 20 are those items that I call, now don't laugh, but I call having high resale value on the street. Items like gold and silver solder used to repair printed circuit boards, and any other high-cost item that is used by maintenance to do either a maintenance requirement or repair. If you have items like that, we generally make a recommendation that those items should be housed in a bonded storeroom within your storeroom. In other words, it's a smaller, self-contained, not only under lock and key, but under security relative to who is authorized to go into that bonded area. And last, we have packaging equipment and supplies where we're actually going to ship items to a supplier for either repair or replacement. And again, 22 signifies other requirements that you may want to add to this list of inventory policies. Again, the inventory policies must be supported by top management, and that's not only the top management of the maintenance organization, but the top management of the corporation or the company in total. Now, moving on to pages 5 and 6, we're going to discuss the various inventory class codes. The inventory classification system is, again, something that we designed for our clients many, many years ago. It is another way to identify the reason for storage in the storeroom. Remember, the inventory management system addresses the two questions, when should I order, how much should I order, and the inventory record would identify the inventory control technique. Now, this is over and above the method of analyzing the accuracy, if you will, of the inventory control technique. It's another way to identify the way materials are being stored and why. So starting off with class 1, this is an item by our definition that is not an integral part of the preventative maintenance program or the major or minor overhaul system. It is something that if we didn't have it on the shelf, it could lead to the shutdown of let's say, a power station, a power distribution system, a major conveyor line, a major process line, or whatever. We probably may want to have one item on hand. The inventory technique would be generated via a min-max system. The max would be 1, the min is 0. When I issue one out, the order quantity would be 1. You'll also notice that we've identified some 5 definitions for a Class 1 item. As 1A indicates, the item is not normally stocked by the supplier, which means that when you establish the min-max requirements, you've got to make certain that you understand the vendor's lead time, because in some rare cases, you may want to have the max be 2, the min be 1, the order quantity still be 1, but that minimum of 1 assures you that you still have 1 on hand to support the next unplanned requirement if one unplanned requirement occurs. Item B is the long lead time of the item. We have some clients where the lead time for this item is 9 months or longer. That means that the supplier actually has to purchase raw material and literally go through a series of various manufacturing or fabrication steps. So again, the lead time is going to be extremely important when you establish the min-max procedure. And remember, these items are stored in the warehouse, and we may want to consider a separate storage area for inventory class code 1 items. Item 1C indicates that the item is unforecastable. In other words, you can't make a forecast of it until there's actually an unplanned requirement. So you really are, at odds end in terms of what should be the minimum and what should be the maximum that we're going to establish. The ground rule generally is look at the vendor lead time and then determine if an item was used and it was replaced, let's say during a 5 to 6 month period, what are the chances that you will need another replacement? And this is done through analysis, and it should be, the analysis should be provided to you by your facilities engineering group or maybe by the OEM that is going to supply the item to you. Item 1D talks about the lack of the item could shut down, as I indicated earlier, a major piece of equipment or process or other applications. And 1E signifies that the item is not readily substitutable, which says if I didn't have it on hand, I don't have anything else that I could use as a substitute until I actually purchase the correct item. So those are the definitions and some of the bases for developing our Class 1 code. Class 2 is a byproduct of purchasing spare parts when a new asset is purchased, when a new piece of equipment is purchased. At some cases, you'll find that if you purchase additional spare parts when you purchase the equipment, you could get a tremendous quantity or volume discount from the OEM. Those items would go into the storeroom, and they ultimately will be used by the PM program. And during that period of time, prior to being used by the PM program, they are recorded as a inventory class 2 item, and at the point of usage, they will be transferred into either a class 3 or some other classification, which is an integral part of this analysis. Item 4 is the safety stock investment for inventory for future unplanned requirements. Now moving forward to page number 6, items that are part of the vendor stocking program would be identified as inventory class code 5. Bench stock or 2-bin items is that material that is housed in the maintenance repair shops. Again, the storeroom is responsible to replenish inventory when replenishment is required, and those are inventory class 6 items. Where we have a supplier that supplies a package quantity, those are identified as inventory class 7. Where a supplier has a minimum identified with his or her shipment, then that is identified as class 8. So classes 7 and 8, we have to follow the minimum or the package quantity as identified by the supplier. Shelf life items, I've already addressed that, and that is a requirement for shelf life codes. The extra security items are those items that we want to consider being housed in the bonded crib. And if we have 2 or more locations for, let's say, facilities within a corporation with having the same part number, we can address the combination of purchases by pooling the requirements of the 2 or more facilities at the time of purchase. Those items are identified as inventory class 11. You may set up a blanket order system for a supplier, issue one purchase order at the beginning of the year or the beginning of your fiscal year, and then release against that on periodic requirements, and those items would be identified as inventory class 12. In some cases, you may find that there may be materials left over from an engineering project. And if those are put into the storeroom, that overage quantity should be identified as inventory class code 13. Now, the key to success in this class code is those parts must be an integral part of the storeroom program. If we do not have part numbers for items that are in excess of, let's say, an engineered project, then it's up to the responsibility of the facilities engineer that headed that project to have final disposition made. Don't use the storeroom as a dumping ground for excess inventories. Where we have a consigned material in from a supplier, those are coded inventory class code 14. The storeroom would have a special storage area for those items, and the financial department should make certain that we have some form of an insurance policy that covers those items financially, so that in case of fire or theft, that we are financially covered for the particular loss of that inventory. Remember, the vendor owns the material. That's what consigned in means. You pay for it only when you use it. And that is another key byproduct of the vendor stocking program. Contractor project items are identical in nature to item 14, and that is where we have a project. It could be an engineered project or a plant expansion, and the contractor would request that we house the material for him. One of the key considerations, again, is to make certain that we have security of the items and we are protected legally by some insurance underwriter. Management may want to approve purchase requisitions or purchase orders prior to their release to suppliers over and above a specific said amount. We could code those items as inventory class code 16, and therefore management could get a printout from a CMMS program or manually some type of report from a manual system for the management approval prior to placing the order. But remember, where we have management approval items, the management approval time, the lead time for that approval process should be added to the integral aggregate lead time of the item. The last item, number 17, not on this page, but the last item pertains to vendor certification. Remember earlier I said we can have vendor auditing, and then ultimately we can get into vendor certification. So those vendors that are certified by part number could move into a JIT application. Now, item 18 addresses the warranty items, and those pertain to the longevity of the item supplied by the supplier. Now, we have covered 18 different inventory class codes, and you may ask the question, Frank, are there more class codes than 18? And the answer is yes. Many of these class codes can be utilized by more than one class code by a part number. So a part number may utilize, as an example, safety stock associated with a vendor unit package quantity. And therefore, we would have 2 or 3, depending on this circumstances, 2 or 3 class codes combined. In those cases, my recommendation is to continue on with class code 19, 20, 21, but indicate the different class codes that comprise those classification codes that are listed in this exhibit. Try not and box yourself into 2 or more class codes in the item master record. It can become confusing. Document it and show it as a particular source document by itself. Now, moving on to page number 7, we're going to address the differences between planned and unplanned requirements and actually show you how they are recorded in an inventory record. There are 5 pages that address the planned and unplanned requirement applications. They go from page 7 to page 7D. But I'm going to start off with page number 7 and address and identify the differences between planned and the unplanned maintenance work orders. As page 7 indicates, we are going to review the differences between planned maintenance work orders and those that are unplanned. Now, the planned maintenance work orders actually are a derivative of the maintenance requirements from the maintenance management program that we looked at on pages 3 and 4 in section 1. And if you remember, the maintenance management program, item number 1, indicated 3 things. It identified the assets, their related spare parts, the type of maintenance requirements, and also the frequency of those maintenance requirements. Here we're addressing the maintenance requirements. The first planned item is planned maintenance checklist. Now you notice there's a little bracket outside that ties that together. And wherever you see that bracket, and there are 3 of them down in the unplanned section, that's just one long sentence, if you will, broken into 2 short sentences, and it's a continuation. So the first one under planned is the PM checklists. The second would be the minor overhauls. The third, major overhauls. And then we could have facilities expansion, which is all planned, and likewise projects. Projects are probably going to be in a shorter time period than facilities expansion. Now, all of the labor and all of the spare parts that are planned are going to be recorded in the item master record in that sub column headed planned requirements. And in the next page, we have 2 illustrations for 2 different part numbers that identifies how planned requirements are recorded, when they're recorded, and likewise when unplanned items are recorded and when they are recorded. Now, in the bottom portion of page 7, we have the unplanned maintenance work orders. The first one would be an emergency order, and then the next one would be those maintenance work order requests. The third are standing maintenance work orders, and that could be a bench stock program where the storeroom, as I indicated earlier, is replenishing inventory that is located in a repair shop or repair shops. Other things like periodically going through the facility looking for airline leaks, water leaks, and any other observation that may be done on a periodic basis. And of course, when you find a condition that should be repaired, then a repair order would be issued, which would be considered an unplanned maintenance work order. And the last would be those miscellaneous requests that can come in from people outside of operations. And that would involve areas that, let's say, could be in a non-manufacturing environment like order entry, engineering department, where they may require some maintenance support. The key now is to remember that we separate the requirements of spare parts into planned versus unplanned. Then we're going to total those at an appropriate time element. And once we continue to track the differences between planned and unplanned requirements, if you're typical of many, many other companies that are doing this, you're going to find that you're going to have a ratio of approximately 80% planned and 20% unplanned in your aggregate inventory. That also indicates that we could take that 80% of planned requirements by part number and move that planning concept into vendor stocking programs. What that is going to do for you is to support the reduction of inventory investment, but most importantly, it's going to reduce the carrying cost associated with that inventory investment. And if your carrying cost is typical of others for the industry as it exists today, it will be probably 20% per dollar per year. Another way to look at that in aggregate terms, if I could reduce inventory investment by $100,000 at 20% per dollar per year, I can save $20,000 in investment of carrying cost. And that's a recurring savings. That means if I continue at the same level of inventory investment the following year, I'm going to save another $20,000 in carrying cost. Now, my question is, how many different computerized programs could you buy for $20,000? What type of counting equipment would you need? And the money is there to purchase counting equipment for the storeroom. How much would it cost to put a person on the second and the third shift to support the storeroom? And where would that salary expense come from? From the recurring carrying cost. Now that's only $100,000. If you were to reduce your inventory by $500,000, you're talking approximately a $100,000 annual savings. So my indication here is that the inventory policies we talked about a moment ago, many of those you may feel require out-of-pocket expense, and they may. But I can prove to you right now, by tracking planned and unplanned requirements, you could save the carrying cost and use that money more effectively to enhance not only the maintenance management program, but the maintenance storeroom program. Now, continuing on page number 7A, I have two different inventory records for you to review. The top record is for part number 23144401, and the lower inventory record is for part number 33150-05. Now you notice they have 4 lines to each record. The top line is for the period, that's the planning period, and in this case we're looking at, let's say, weeks. These could be days, and that would give us what we call the horizon in the planning of planned maintenance work orders. You see, in unplanned, there's no horizon, because if I knew what I needed, I could plan it. So in the planned, we're looking forward. In the unplanned, we're taking history, doing some calculations. When should I order? How much should I order? And we're going to plan projected inventory to be on hand for future unplanned requirements. So with that in mind, let's take a look at these 2 records. The first record on top indicates that in period 1, we used an unplanned requirement. When I moved to period 2, I could then add planned and unplanned together and come up with a total. Since there were no planned requirements but only unplanned, then the total would indicate, as the unplanned total did, that I used 1. So the thing I'm bringing across here is that in order to add planned and unplanned requirements, you have to move out of the planning period you currently are in into the next planning period, and then you could summarize both the planned and unplanned requirements. In the top record, I indicate that we are currently in period 10. So the only thing that I have to consider at this point in time is I have a planned requirement for period 12, 14, and 16. But if I look back in history, I could see the individual quantities that were planned by period, those that were unplanned by period, and then the total by period. And really, that's all it takes from a standpoint of training to know how to read these records, planned, unplanned, and total. The system, in order to put this into effect, would be what inventory control technique do I use for these 2 part numbers? Well, there are other factors like cost and lead time and where used that has to be incorporated into the inventory management program. But here we're only concerned about how to read, identify, and actually develop the inventory records that would address planned and unplanned and total. In the second record, we are all the way out to period 15, and we have the sum of the planned and unplanned historically from periods 1 to 15. We're now moving into planning period 16, so I could now summarize the unplanned of 1 usage in period 15 and show that as a total. And again, looking forward, the only requirement that I have at this point in time is there are 2 items required for period 17. So this gives you the opportunity now to address how your inventory system should work. It should work like these 2 records signify. If you are going to computerize your system, then you must have all 4 lines or sub-records in an item master record. The planning period by time, the unplanned record, the planned record, and the total. If you are in a manual environment, the inventory record, the manual record, should likewise give you the same capability. Now, in page 7B, I'm addressing for you exactly what I had just gone through on page 7A. The first paragraph addresses what the various maintenance work order requirements are, that is planned and unplanned. The second paragraph addresses the planned requirements must be recorded in the planned record, and the unplanned requirements must be recorded in the unplanned record. So not only are we showing you physically what the record looks like in 7A, we're also giving you the instructions relative to how those records actually function. The last paragraph addresses that the inventory record should have the capability to show total item requirements, as I indicated with you when we looked at page 7A. Now if you turn to page 7C, in this case I'm actually identifying for you and cross-referencing the two part numbers to their respective inventory records. Now, like I said, there are 4 pages here that you want to consider when you talk about planned and unplanned requirements. Pages 7, 7A, B, and C, respectively. And if you can go through this a few times and get thoroughly familiar with it, I know you will be in a position to set up the records for the inventory management program properly. Now, what I want to do is conclude with page 7D, the total in terms of when should I order and how much. And that we're going to look at in the next 2 pages when we address those 2 questions independently. On the last paragraph on page 7D, I've also provided you with the dialogue in writing relative to the 80% planned and 20% unplanned. Now remember, that's an average. Companies that are in a continuous process environment, petrochemical, the box board, the paper industry, food processing, chemicals of different types, even the canning and bottling industry, their planned requirements can go as high as 95+%. So again, everything is relative to the differences of actual usage. Once you institute the planning process in maintenance, that is the PM, the major minor overhauls, once those are instituted, then you will start to develop these percentages. How long will it take to actually solidify those percentages? It depends upon the size of the operation, the number of assets that you are maintaining. My general answer is anywhere from 1 to 2 years. But it takes 1 to 1.5 years to basically install a PM program. So those time elements are not really that far out into the future, especially if you start the planning process today. Don't wait. We're giving you the tools, we're showing you how to do it. Now it's going to be up to you to execute that plan. Now on page 8, we're addressing the 2 questions: when do we order and how much do we order? And in this case, the ordering matrix that I identified for you earlier is on page 9. Now, when to order, there are 3 answers to that question. When we have a planned requirement, when we reach an order point, or we reach a minimum under a min-max system. There are several answers to how much. When it comes to a planned requirement, there are 5. We order to order, we order to order plus a yield factor, and we'll describe that in a moment. We order to an economic order quantity, we order to a vendor's minimum or to a vendor unit pack. When we reach an order point, we have 3 answers to how much. When we establish an economic order quantity, or we use a vendor minimum or a vendor unit pack. And when we have a min-max requirement, when we reach the min, there are two ordering criteria for the min-max system. If the minimum is 0, the order quantity is max minus the min. If the min is equal to 1 or more, and depending on how many are on hand when we issue material from the storeroom, and we go below the minimum, then the order quantity is max minus the min plus the deviation below the min. And again, we have examples on how all of these techniques work. The other three are the economic order quantity, a vendor minimum, or a vendor unit pack. Now, let's address the ordering matrix by number. We have a 2-digit field for our inventory management ordering matrix, and they're very simple. They're extracted right from this exhibit. For the first when to order, when we have a plan and a how much, the ordering matrix would be 11, 12, 13, 14, or 15. Simple. When we are under an order point system, we would have our ordering matrix to be numbered 21, 22, or 23. And when we are in a min-max environment, we have an ordering matrix of 31, 32, 33, 34, and 35. So those 2-digit ordering matrix numbers would be identified in the item master record, and if we weren't sure what that ordering matrix number was and how it was developed, we can basically go back to this document, or in a CMMS system, this ordering matrix could be a little window in the inventory management application, and it would be there every time we had to go through a reordering analysis for each and every part number. And last but not least, you'll notice that there is a note on the bottom of page number 9, and it addresses the shelf life code. And the shelf life code, again, as I said earlier, is an expiration date for an item. Don't use the item if the shelf life code was equal to yesterday or back. And the shelf life code is analyzed relative to the order quantity developed. And if you feel that even though we purchased a new lot size and we brought it in from a supplier and put it on the shelf for future unplanned requirements, if it is conceivable that we could go beyond the shelf life code, which means inventory could be been on hand beyond the shelf life code, then we should adjust the order quantity accordingly. We don't want to utilize material that could cause asset or machine downtime. Now, moving into the next series of pages, starting off with page number 10, we are going to look at the different ordering techniques as identified on the previous page, and these techniques are identified in terms of the development and the derivation and definition of each technique. There are 4 pages that comprise this inventory management formula series, and they are pages 10, 10A, B, and C respectively. And I'm trying to utilize the same format as we had in the previous ordering matrix to give you some continuity. Item number 1, MRP, is material requirements planning. Order to order. If you need 3, you order 3. If you need 6, you order 6. But what if the supplier says, I have those in unit packs of 4 and you needed 3? Then I'd have to change the ordering lot size to meet the vendor package quantity. The yield factor in item number 2 is a known loss. And a little later, I demonstrate how that yield factor is actually applied in an illustration, but let me at least walk you through some of the data that is actually covered in a notebook. First of all, let's say I need a 95 feet of 3-inch aluminum pipe for a project. That's a planned requirement. The supplier supplies 3-inch aluminum tubing or piping in 10-foot lengths. That means I'm going to have to purchase 100 feet. That is 10 pieces. Immediately I know that I'm going to have a 5-foot yield, or what we call a cropping, or some people call it a fall off. If the purchase price of the 100 feet is applied to the planned maintenance work order, and the 5-foot cropping occurs, the value, the financial value of that 5-foot piece, or the yield, is 0. Therefore, I should develop the procedures on how to physically dispose of that particular yield factor. And that's all that's to it. We want to make sure that the total purchase cost of the item is charged to the job. Therefore, the yield has 0 value, and we certainly don't want to put that 5-piece of special 3-inch aluminum pipe into the storeroom and start to, generate stocking requirements for those items that may never be required. Keep the storeroom simple. Charge the yield to the job and dispose of the yield through normal disposition. Now, when I talk about financial costs, we certainly should address this with our financial department to make certain that they understand the ramifications of how we're going to cost the work order and how we're going to dispose of that yield. The third element is EOQ, economic order quantity. Here's the formula for it, and it's very simple. The people on the production side have been using this formula for many, many years. EOQ is equal to the square root of 2 times the annual usage times either the purchase cost or the setup cost if the item is manufactured, divided by the carrying cost multiplied by the unit cost. All of this data comes from your inventory record. And basically what we're trying to develop here is the economics of purchase versus the economics of carrying inventory. We do have an illustration that we will go through with you. It's in this section of the notebook, so you know how that particular inventory control application works. The fourth one is the reorder point. And this is a calculation actually of inventory on hand, and that inventory on hand is identified as reorder point. So it merely says in basic English, when I reach the reorder point, which is calculated, I should reorder. Therefore, the reorder point consists of 2 portions. The first portion is average usage times the lead time. That portion I call working inventory. That's the first type of inventory which is used. A little later, we'll show you an order point system graphically, and it will become very clear in terms of my definition of working inventory. The second portion, which is MAD, which is an acronym for mean absolute deviation, and that is calculated, and again we're going to show you how that's accomplished, and you multiply that by a safety factor which comes from a table based upon a pre-selected service level or fill rate out of the storeroom. Then that portion of the order point is called safety stock. So the order point is equal to average usage times the lead time plus the mean absolute deviation times the safety factor. All of this data is an integral part of the inventory management program addressing the question, when should I order? Now, Item number 5 addresses the safety stock, and I've already gone through its derivation when I discussed the second half of the order point formula, MAD times safety factor. Now, I want to have you make a cross-reference relative to the order point formula and indicate that the safety factors are going to be found on page 27. So when we get to that particular section, you're going to see how the safety factor is derived as a function of a predetermined service level or a fill rate out of the storeroom. Now, moving on to page 10B, item 6 is the first of the two min-max applications. In this case, the order quantity is equal to the max minus the min, therefore the min is equal to 0. And we go through the definition of the ordering requirement. However, if the min is equal to or greater than 1, then we have the second formula, which is in the middle of the page, which indicates that the order quantity is equal to the max minus the min plus the deviation below the min at the point I actually issued material out of the storeroom. Now, this brings us to a point where I would like to merely indicate the integration of the storeroom to the inventory system. Number 1, we have a yield factor to consider. The storeroom physically disposes of that material. Secondly, we have an order point system. It's a pre-calculated bin on hand when I should order. Bin on hand pertains to the storeroom. Here we have a min-max system where we're talking about the ordering quantity. And yet, under the second ordering criteria, when the min is equal to 1 or more, that is really an integral part of a storeroom issuing requirement. What I'm basically alluding to is that the inventory system and the storeroom system in these illustrations are working with each other. If the inventory in the storeroom bin on hand is in error, you could imagine what's going to happen to the order point system and to the min-max system. It's not going to work properly. Now moving to page 10C, continuing with our different inventory management formulas, the vendor minimum, as I indicated earlier, is established by the supplier. The vendor unit pack is likewise established by the supplier in item number 8. And for those of you that have a inkling toward JIT, and in the last few pages of this section, we address the characteristics that must be in place to institute a JIT program. But from this standpoint, JIT is similar to MRP or MRP with a yield factor, but the time period is smaller. What does the time period just in time mean? It's a function of maintenance management to establish those time elements with your key suppliers that are going to support the JIT program after they have been certified. It takes 1 year to certify a supplier, but the waiting time is well worth it, because here's another case where I could plan and schedule maintenance work orders without having any inventory on hand. It depends upon that ratio of planned versus unplanned by part number. Now, we also indicate that any of the above ordering requirements, like we had noted in our maintenance inventory management ordering matrix, we address the shelf life code. And I can't illustrate the importance of that shelf life code. And after reviewing many CMMS programs, many of them do not even address the shelf life system. Now, moving into page 11, we have 10 pages, and they go from page 11 to 11I. And here is where we're actually looking at different examples of how those formulas that we looked at in the previous section are actually put into functional use. So the first one, we're going to address the MRP application, and that is actual to actual. And then we're going to be looking at MRP plus the yield factor, and I've identified that. And I've tried here to use the same scenario that I did previously with that 3-inch special aluminum piping where we needed 95 feet. We can only purchase those in 10-foot lengths. So all of this description on page 11 identifies what I told you previously are the results of the yield factor and the procedure that is required. You've got to develop this to physically dispose of that yield factor properly. Now moving to page 11A, we're addressing the economic order quantity. So I have developed for you the formula. Again, I repeat the different definitions of the characters that are shown in the formula. There is a note at the bottom of the page that addresses that all of this data comes from the inventory record. That is, if your inventory record is set up properly. And continuing on page 11B, we're showing you the data for a EOQ example where A is equal to 135 units, S is the purchase order cost of $20, I is the carrying cost of 25%, and C is the unit cost of $6. So we want to solve for EOQ, and you will notice step 1, I again have identified the EOQ formula. This is a technique that I employ you to use. Wherever you're going to develop a equation and you're going to use that equation, always start out by putting the first step, identifying and showing the equation. This way, you're not going to be carrying anything up here from a memory standpoint and make mistakes. The second thing is when you go through the step-by-step iterations of utilizing the equation, don't take shortcuts. Take the steps by the numbers, 1, 2, 3, 4, and so forth. Because that gives you the building block, it shows you the steps, and if there was an error, let's say, you could go back to the previous steps and make corrections if corrections are required. So here in step 2, we're taking a formula from step 1 and we're putting the data into it. And then step 3 is the actual calculation, which is multiplication of the numerator by the denominator. So since the numerator and the denominator in this illustration each have dollar signs, those dollar signs cancel each other out, and therefore we come out with the partial answer that is in step 3. We go through our division, and then we take the square root of the 3600, and therefore the EOQ is 60 units. The key byproduct of understanding EOQ is as follows. Always look at the order quantity and compare it to the annual usage. In this case, our annual usage is 135. 60 divided into 135 is telling me that we're going to have a little over 2 turns a year for this item. If you desire to get higher turns, then reduce the economic order quantity. All I'm trying to indicate, attest to turnover analysis is to take the EOQ quantity and divide it into the annual usage. Remember earlier I said I could show you how to analyze turnover by part number? Well, here's an illustration of how I do that. And if I wanted to set up an inventory management policy that says I don't want to have EOQs that provide less than 4 turns a year, then this would be an illustration of making a change to the EOQ. Now, turning on to page 11C, we're going to look at an illustration for the order point system. And again, for continuity purposes, we've showing the order point formula, and we're showing the data elements that comprise the order point formula. And if you turn to page 11D, we're going to look at some data requirements where, first of all, we're looking at an annual usage by month, starting off with the month of January through December. So these are summarized usages by month. And if you turn the page to 11E, you'll also notice that the lead time is 2 months. We have indicated that for this part we want a 95% service level or a 95% fill rate out of the storeroom. The opposite of that is we could have maybe 5% of the times we could be out of stock, but if our lead times are accurate and we follow up on vendor delivery, we should not experience any negative service level. But in this case, because of the where use code and the item based upon its usage requirements, management here has indicated that a 95% service level is accurate, and therefore if I go to the table for the safety factor service level, then the safety factor is equal to 2.06, and we go through the calculation for the order point formula. So the first thing we do on solving for order point in step 1 is to calculate annual usage. If we added up the individual monthly usages on the previous page, we would have a total annual usage of 36. Since there are 12 planning periods in the exhibit on the preceding page, we divide 36 by 12, and therefore the average monthly usage is 3. Moving on to page 11F, what we're trying to do now is to determine the differences between the actual usage and the average usage, and then what we want to do is to summarize those differences and divide by the number of planning periods. That end result is mean absolute deviation. Mean means average, absolute is without regard to sign, and deviation is the difference between the actual usage and the average usage. But we want to find the average of that. So on page 11F, we show our 12 months. We show the actual usage for each of those months. We're going to subtract the average usage, but we're going to do it in absolute terms. We forget the plus or minus signs. So the column on the right-hand side is the difference. The total is 14. And if you turn to page 11G, the next page, you'll see that what we're going to do is divide 14 by 12, and therefore mean absolute deviation is 1.17. I have average usage of 3. I have the lead time of 2 months. I have mean absolute deviation of 1.17. And I know my safety factor for 95% service level is 2.06. Now I put all of that data into my formula, and I multiply and I summarize, and 2 times 3 is 6, and 1.17 times 2.06 is 2.41, And you notice I have a notation there, and it says irrespective of the decimal equivalent, always round up. So I'm going to change 2.41 to 3, and therefore my order point is equal to 9. And since MAD times the safety factor in step 6 is also the formula for safety stock, then therefore the safety stock for this illustration is equal to 3. It has to be the same 3 as we had when we developed the order point. And again, I encourage you to go back over these particular exercises. And then with the data that you have in your own inventory system, start to put some of that data into each one of these techniques until you become thoroughly familiar with how these applications actually work. Remember, training is the key to a successful stores program. And the inventory system drives the purchasing system, and it is the purchasing system that actually, through the vendor supply base, drives the storeroom, in addition to maintenance, work order, planning, and scheduling. Now, continuing on page 11H, we have an illustration of the min-max system where the minimum is 0. And again, we're showing the max and a min. We're solving, so again, we're indicating what the formula is. Order quantity is equal to max minus the min. We insert the data elements, and we come up with the order quantity to be 4. If you turn to the following page, we have the second illustration of a min-max system. Here, the max is 8 and the min is 3. We show the formula, but we indicate that we had 4 on hand. We issued 2 units, and that is the tie-in between the storeroom and the inventory system. That means I went 1 below the minimum, and therefore the order quantity is 8 minus 3, or 5, plus the deviation of 1 below the min, and therefore the order quantity is equal to 6. Now that concludes the different techniques relative to their examples. Now, one of the other major applications we talked about previously, and that's the ABC system, because that is used to establish vendor stocking programs. It is also the input into the cycle count program. So we want to start off by analyzing the data that is on page number 12. And this section under ABC has 8 pages to it, and it is finalized on page 16C. Now, starting off on page number 12, I want to go to this particular report, which is an ABC report, and at least identify for you the heading, explain the heading, and then look at some of the data in the report. Starting up on the top on the left-hand side, that left column item number is part number. Now, there should be a column for the description and likewise a column for the unit of measure. But to try and put all of this information onto one 8.5 by 11 document so it'll fit nicely in your notebook, I've left some of that data off, but I do allude to it during this section of the inventory management program. The next section going to the right is item card count. That is nothing more than our ability to count the number of part numbers in this ABC analysis. We start at the top with 1, and with additives of 1, we go all the way to the bottom, to the last item in this analysis. So you could see there's 10,988 part numbers in this system. Since, again, we're trying to show you how this application works, on page number 12, we've only selected on a random basis the items that are shown here. Moving again to the right, that percentage column is the percentage of the item by part number and its percentage to the total. In order to get that percentage column, we have to take 10,988 and divide it into each one of the above. That means for this illustration, there are 10,987 divisions that occur. Right away you could say, there's no way I'm going to do this manually. No, we don't expect you to. And therefore, this is a candidate for computerization. But let me just indicate one thing. If you don't have this application in your current, let's say, CMMS program, or you are strictly in a manual environment, you could probably go to a service bureau and they could run this report for you, maybe for a cost of 3 to 5 cents per line item. Because you're not computerized, that doesn't mean that you should not consider this application. My advice is to consider it very strongly. Why? It's at least the input into vendor stocking programs. Continuing on now, the next two columns, annual usage and unit cost, come right from the inventory record. Those are the same two values that we could have used in an EOQ equation. So we multiply the annual units times the unit cost, and we get annual dollars that are sold out of the storeroom. Some people refer to that as annual usage value. Then what the system does, it sorts the annual usage value from the highest to the lowest. In this example that you're looking at, that sorting process has already been accomplished. So the first item on the top is the highest annual usage, and if you kind of scan down to the bottom, wherever annual usage value is 0, that means there was no usage, and 0 times an annual, or excuse me, 0 times the unit cost would give us 0 annual usage, so those items would be on the bottom. The second column from the right is what we call a cumulative dollar sales or cumulative annual usage value analysis. Cumulative is really a byproduct from descending annual usage. And we have an illustration. We're going to show you how to do that. In fact, there's a homework assignment for you in this section, so at least you'll have an opportunity to go through the mechanics and get a feel for the exercise itself. But in this case, the first item on top is its own cum. Then I would add the next highest annual usage value to the preceding cum. And it would continue down until I have the total. Now don't try and take the second line of 77,000 and add that to the 158,000 for the previous cum. You're not going to get that total. Remember, the first item is item 1, and the second line is item 13. So items 2 to 12 are not on this report. But cumulatively speaking, this company has issued out of its storeroom a little over $33 million worth of spare parts. Now again, to find that percentage, line item by line item, the percentage of cumulative annual usage, we divide that 33 million plus into each one of the above. Yes, there's a total of 10,987 divisions, and that is precisely where we get that right-hand column, which is the cumulative percentage. Now, after we're going through all this work and this divisions and so forth, what does that mean to me? And that would be a logical question that you should address. The answer is in the procedures that follow this exhibit. But let me at least address the A, B, and C item right now. The A item, by definition, says 20% of my part numbers may represent 70 to 80% of my cumulative usage value. So what I would do is I'd go down that third column from the left until I found 20%, and then I would read across, and in this case, the cumulative percent is 71.6%. Those 2,000 plus items would be called the A items. Another 15 to 20% of the part numbers could represent another 15% of the cumulative usage value. And those would be B, and then the balance would be C. So the procedures are on the following pages, but before we get to the procedures, starting on page 13 is your homework assignment. So let's go through that first, and then we'll get into the procedures, and then ultimately, as I said before, in the cycle counting. You have 12 part numbers listed on the left-hand column. You also have the annual usage, and you have the unit cost. Now what I want you to do manually, but use a calculator, is multiply annual usage times unit cost. And then you post that under annual usage times unit cost column, second column from the right. Once you've gone through your 12 calculations, then what you're going to do is look at those various annual usages and select the one that has the highest annual usage value. And then that right-hand column called rank, you put that as 1. Highest annual usage is 1. And then you're going to go to the next highest annual usage, which is 2, and so forth, until you've filled up that ranking column, which will be randomly 1 to 12. Then if you go over to page 14, we have the second worksheet for this homework assignment, and you're going to record the part number, which would be the highest annual usage to the lowest. So once you get your 12 part numbers assigned, then what you're going to do is you're going to take the annual usage value, which is the second column from the right, and record that by part number in the second column from the left on page 14. You're going to run a cum total, and then based upon the parameters as established by the procedure, which is on page number 16A, item 8, and we'll get to that in a moment, you're going to develop those items which are A, starting at the top, the next group B, and the next group C. Once you've developed that, you're going to accumulate the percentages for the A, the B, and the C items. And that would complete the second exhibit for your homework. And the last one is on page 15, and that pertains to what we call ABC analysis. You're only going to use the top 3 lines in this exhibit. So under the classification, you're going to put ABC, then you're going to put the percentage of items, which is going to be very easy. As an example, if I had 4 A items, and that was 4 of 12, then the percentage of items would be 33 1/3. I would go back to the preceding page to get the dollars per classification and also the percentage of those dollars. And that is done once a year, the annualization of the ABC analysis. And as I indicated on page 16, we start the procedure. And you'll notice that the first step, I indicate you need part number, description, unit of measure, the unit cost, and annual usage. Guess what? All of that data comes from your inventory record. Then you're going to multiply annual usage by the unit cost. That's step 2. You're going to rank or sort the highest annual usage to the lowest. That's step 3. Then after step 3 above, all items should be counted, which is that second column from the left on our ABC analysis. And we start off with the highest one, and the lowest would be whatever or how many items you would have in your inventory. And then you're going to accumulate the annual usage value, and once you've developed that, then there are 2 divisions that take place. First of all, the total number of items into each one of the above in that column, and the total cumulative annual usage into each one of the above in that particular column. Now I have my percentages by part number. I also have the percentages in terms of cumulative annual usage value. Now I'm ready to go into step number 8, and we have the guidelines that develop the parameters relative to the A, B, C items, and I went through that earlier with you, but in this case we're indicating 20% of the part numbers would represent about 80% of the cumulative annual usage value, and then another 20% of the part numbers could represent 15 to 20% of the cumulative usage value. Those would be the B items, and then the last would be the C. So I do have the parameters established now for the A, B, C. Once I identify that, I now can move into 2 applications. One would be vendor stocking, which we're going to identify a little later, and the other one would be the input into cycle counting, and we'll be talking about that very shortly. There's also a note which is at the bottom of page 16B, and that illustrates that if you wanted to add additional characters like D, E, and F, you can do so, except you go back to the previous page in step number 8, and you're going to have to establish the parameters for the new A, B, C, and likewise the D, E, F requirements. And last but not least, on page 16C are some of the key byproducts of the ABC analysis. The first would be a reduction of inventory investment through the vendor stocking program. Again, we're going to go through that in detail and show you how to accomplish that. The second major byproduct is the input into cycle counting. The third major byproduct, especially on the A items and some of the critical B's and C's, as they appear on the cycle counting program, purchasing can get a copy of that report to verify the accuracy of vendor lead time. D is the input into a priority program in processing purchase receipts and filling, let's say, maintenance work orders, where A items, we'd like to get those into the storeroom program as quickly as possible, and then if there are planned maintenance work orders, we want to apply those immediately and get those out into the equipment so we can get high turnover for the A's, likewise the B's, and subsequently the C's. And as item E indicates, it's the input into an obsolescence program, and we did discuss obsolescence in section 3 on page 5, so it's something that you may want to go back to and make reference relative to that particular program. Now what we're going to do is move into the procedure, the outline for cycle counting.